In Lesson 5.4, you're going to be solving compound inequalities. You'll solve compound inequalities containing the word and you will also graph their solution set. You'll also solve compound inequalities containing the word or and graph their solution set. The first vocabulary word is compound inequality. Make sure to write down that definition. A compound inequality containing and is only true if both inequalities are true. And then on a graph of a compound inequality, where the two inequalities overlap is called the intersection of the two graphs. What you can do to graph an compound inequality is to graph each one separately and then determine where they overlap. In this case, this is the intersection right here. For example 1, it says to solve and then graph the solution set. So notice that the first step is to express the inequality using the word and then you're going to solve each inequality. So first we break it up into -2 is less than or equal to x minus 3 and take care of that one. And then we also do x minus 3 is less than 4 and solve that one. Then we're going to graph each of those separately and come up with our intersection or solution to the compound inequality. At the top of page 307, let's try a couple guided practice problems together. It says to solve each compound inequality and then graph the solution set. So for the first one, we have y minus 3 is greater than or equal to -11. Add 3 to both sides, and we get y is greater than or equal to -8. We also have y minus 3 is less than or equal to -8, plus 3, and we have y is less than or equal to -5. So notice that the answer right here shows that y such that -8 is less than or equal to y, less than or equal to 5. Those are both closed circles at -8 and -5, and the solution set is joining those two in between. For 1b, we're going to split that into two separate inequalities. So we have 6 is less than or equal to r plus 7, and we also have r plus 7 is less than 10. We will subtract 7 on the first inequality and get 1 is less than or equal to r. Another way to write that is r is greater than or equal to 1. And on the second inequality, subtract 7, r is less than 3. R is less than 3. We can write that compound inequality as, oops, I made a mistake there, that should be -1. R is greater than or equal to -1. -1 is less than or equal to r, and it's less than 3. On a number line, that's going to be a closed circle at -1 and an open circle at 3, and the solution set would be joining the two together. In Lesson 5.4, we also have inequalities containing the word or. So another type of compound inequality contains the word or. And a compound inequality containing or is true if at least one of the inequalities is true. Its graph is the union of the graphs of two inequalities. So right here we have x is greater than 2, open circle at 2, arrow to the right. X is less than or equal to -1, closed circle, arrow to the left. And so x is greater than 2 or x is less than or equal to -1 is graphed here. When solving problems involving inequalities, within means it to be inclusive. So use greater than or equal to or less than or equal to. The word between is meant to be exclusive. So you're going to use less than or greater than. Please make sure you have that in your notes. For example 2, we're going to write and graph a compound inequality. So again, taking words and translating those to numbers and symbols, and then graphing the solution set. Make sure you take time to read through this example before trying one on your own. At the bottom of page 307, we have a guided practice problem. A company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall the action figure must be. Well, it must be at least 11.2 and at most 11.4. And so what we have is the height in the middle, and it has to be between those two numbers. So I'm going to fill that in with less than or equal to, and then on a graph, of course, that would be 2 filled in circles at each point, and then joining them together for the intersection. For example 3 on page 308, we're going to solve and graph a union. And so what we have here is a compound inequality containing the word or. So what we're going to do is solve each of those inequalities separately, and then we're going to graph on a number line. In this case, we have a closed circle at -3 with an arrow going to the right, and on the right side we have m is greater than 5, and so we have an open circle at 5 with an arrow to the right. So we're finding the place where they overlap, and it says, notice that the graph of m is greater than or equal to -3 contains every point in the graph of m greater than 5. So the union is the graph of m is greater than or equal to -3. And the way we write that solution set is m such that m is greater than or equal to -3. For the guided practice problem here at the middle of page 308, we're going to again solve each of those inequalities separately. A is less than 3. And if I add 1 to both sides, we get A is greater than or equal to 4. And when we graph that, we have an open circle at 3, arrow to the left, and closed circle at 4, arrow to the right. And our solution set is A such that A is less than 3 or A is greater than or equal to 4. For B, we have x is less than or equal to 9, so that's a closed circle at 9 with an arrow to the left. And then we also have our second inequality that when we solve it, we get 4x is less than 8, divide by 4, divide by 4, and we have x is less than 2. So x is less than 2 is over here, open circle, arrow to the left. But we are going to say that the solution set is this one right here because it includes the other one. So we have x such that x is less than or equal to 9. Just to review a little bit about compound inequalities for lesson 5.4, we have some containing the word and others containing the word or. And so on page 309, we have a few examples here for you just to take a look at and see. For number 18, we have a closed circle at -1 and a closed circle at 4. And so our compound inequality is -1 less than or equal to x less than or equal to 4. On number 19, we have an open circle at -3, a closed circle at 2. So our compound inequality is -3 less than x less than or equal to 2. Notice on number 20, we have inequalities going in opposite directions here. So we have the or type of compound inequality. X is less than 0 or x is greater than or equal to 3. Same for number 21. We have open circles going in opposite directions. So we're going to write that as x is less than -4 or x is greater than -3. Number 22, two closed circles. So we have x is less than or equal to 3 or x is greater than or equal to 6. And finally, number 23, closed circle at -3 is x is less than or equal to -3. Open circle at 0, arrow to the right, is x is greater than 0. Just make sure you really understand what those graphs look like and how to write the compound inequality. For number 39 on page 310, we have work shown by Chloe and Jonas for doing the compound inequality shown. Chloe started by adding 5 to -5 and adding 5 to 12, but what she failed to do was add 5 to the 3. So if she continued that correctly, it should have said 8 is less than 2x is less than 12, and then you can divide all 3 by 2 to get 4 less than x less than 6. So for Jonas, he chose to add 5 to the -5 and add 5 to the 3, but forgot to add 5 to the 7. So neither Jonas nor Chloe are correct. For your 5-4 homework, I included the study guide and intervention sheet, which will hopefully give you one more resource to truly understand compound inequalities. So we have inequalities containing the word and that is true only if both inequalities are true. The graph of a compound inequality containing and is the intersection of the graphs of the two inequalities. Every solution of the compound inequality must be a solution to both inequalities. So we have two examples here. One where it's shown as two separate inequalities using the word and example 2 is written all together as one, in which case you can separate them out into two, or the part that they don't show on here is doing this as, the part that they don't show is a second strategy, which I'll briefly show right here. What I can do is subtract 2 and subtract 2 again and subtract 2 a third time. So sorry about my pen here, but hopefully you'll see here in just a second that we have subtracting 2 from the left side, the middle, and the right side. And what I have left is -3 is less than x is less than 3 minus 2, which is 1. I got the same answer by separating them out into two separate inequalities, but I just wanted you to be aware of that other strategy that you could use. Notice here we have an open circle and we have an open circle, and the intersection is where those two meet. And our solution set can be written as x such that -3 is less than x is less than 1. So you have some exercises to practice that, and then on the second page you have inequalities containing the word or. And inequalities containing the word or are true if one or both of the inequalities are true. The graph of a compound inequality containing or is the union of the graphs of the two inequalities, and the union can be found by graphing both inequalities on the same number line, and then a solution of the compound inequality is a solution of either inequality, but not necessarily both. So we have an example here of two inequalities using the word or, so a compound inequality with the word or. Notice how that plays out when you solve each one separately and then you graph it. This one has a graph of a is less than 5. We also have a is less than -1. The union is actually a such that a is less than 5. So you have some more exercises here to solve compound inequalities involving or. Hopefully after doing these exercises you understand a little bit more about solving compound inequalities. Make sure to ask if you need extra assistance.